This video will look at circular motion for module 4 of T-level physics. Circular motion is a fairly straightforward phenomenon, as I'm sure you can imagine. It relies on a body, this object, whatever it is. It could be a planet, it could be a ball on a string you're swinging around your head, it doesn't really matter. It's got a mass and it is moving around this circle. Now, to find a circle you need to know the centre point, so we always are interested in the centre of this circle. If you're only looking at something that's moving in a curve, so a car going over the hump of a bridge, then we'll often talk about the centre of curvature. That's the centre of the circle that it would be moving around if it went in front of the circle, which obviously is different purpose. The centre of that circle is key. From the centre of that circle to the mass, we measure the radius. And that radius is key in all of our calculations to do with circular motion. Now, this object is obviously at this particular instant moving in this direction with a velocity of v. Notice that the velocity and the radius are always at right angles. The velocity is at a tangent to the circumference of the circle at that point. Now that's really, really important, because that always stays the same. The velocity is always at right angles to the radius. You will notice, of course, that the velocity is changing direction. It keeps its speed constant, but it changes direction. Now, because it's changing direction, I have a change in velocity, therefore it is accelerating. It does not matter that it's going at the same speed, because it's changing direction, it is accelerating. If it's accelerating by an even second law, there must be a force acting. So we know from this that we have an object that is being held in a circle, and it must be being sustained in circular motion by some resultant force, and we call that a centripetal force. Now, this is something that people often get a little bit confused about. They think that because something is moving in a circle, there is this magical centripetal force that appears from nowhere. Now, that's not the case. The centripetal force is the main mover to a resultant force that happens to cause circular motion. Circular motion is the effect, and the centripetal force is the resultant force causing that effect. Now, it can actually be a gravitational force, a magnetic force, or a combination of multiple forces. But the resultant force acting on the object acts as a centripetal force if it's moving in circular motion. Now, there are a few other variables we can think about here to try and help us to understand the situation. One is that we can look at theta, the angle turned v. If we're moving in a circle, then obviously we're moving around 360 degrees in the rotation, or more usefully perhaps 2 pi radians for one complete rotation. So we can look at, if my object moves from here to here, what is this angle that it is turned through? Now, every point along the radius would be moving at the same, it would move to the same angle per second, even though they're moving at different linear speeds. We talk about their angular speed or angular velocity, which we're going to call omega, or lowercase beta, or omega. And that is the rate of change of the angle with respect to time. If we're going to turn through the entirety of the circle, then that is going to be 2 pi radians. That is going to take one time period t, so omega is equal to 2 pi for t, or if you prefer, 2 pi f, where f is the frequency, how many rotations per second. So already here we've got another few variables to look at. We've got this idea of angular velocity, and we've got this idea of frequency and time period. Now, if I want to work out speed, v, well, I can just do distance over time, which is just equal to 2 pi r, that's the circumference, in one time period t. And then I can combine these two equations, and I can see that actually v is equal to omega times r. So v equals r omega r, and that is a remarkably useful equation to help you to convert between velocities and angular velocities. Odds are the questions that you'll be dealing with will want you to deal in one of those two properties. and it's really useful to be able to switch between them at this point. Now, we've just said that there's an acceleration here, and we can give that acceleration using the formula A equals v squared over r. So if I use this equation to substitute into, you can rearrange to r times omega squared. That is one of the three equations for circular motion. It tells me the magnitude of the acceleration, and this always acts towards the centre. The centripetal acceleration acts towards the centre of the circle. It is caused by a centripetal force, F, and well, Newton's second law just says F equals ma, so F must equal m v squared over r, or m r omega squared. Now these equations form the basis of much of your work on circular motion. You have to make an important choice when you start the question. Which one of the two versions am I going to use? Am I going to use F equals mv squared over r, or F equals mr omega squared? Now, that will depend partially on what information you've been given, and partially on what you're trying to do. If you choose the wrong one, it's not the end of the world. You can always rearrange and substitute in. You're just making a little bit of extra work for yourself. However, from this equation, you will find that so many other parts of physics can be used. The trick is working out what is going on. So if I have, for example, an orbit, well, then I can say the only force acting on my body is a gravitational force. Well, that's gm1 m2 squared. Oh, but if that's the only force and it's causing circular motion, that must be equal to mv squared over r. Oh, suddenly I've got an equation to describe an orbit. What about if I have a body moving in a magnetic field? Well, I've got a charged particle moving through a magnetic field. Well, the force acting on it must be equal to BQB. Well, that's interesting. So it's moving in a circle. Oh, if it's moving in a circle, then the force causing circular motion must be mv squared over r. So those two forces must be equal. Similarly, you can come up with slightly more complex situations with multiple forces acting. So my favourite example I've seen in a past exam question is that involves the drum of a washing machine, and it looks at socks at different parts of the washing machine. So there is a blue sock at the bottom, and we will have an orange sock at the top, and the obligatory terrible artwork. But there are two socks in a washing machine, and that washing machine is rotating. Well, what's the centripetal force going to be? Well, the centripetal force has to be equal. Centripetal force must be equal to mv squared over r. But what is that force? Well, what forces are acting on these two socks? Well, they both have a weight of mg acting downwards, but then we also have another force. We have a reaction force from the drum. So we've got here a reaction force there, we'll call it capital R, and we've got another reaction force there, we'll call it capital R. So what's my centripetal force? Well, at the top, centripetal force for the orange sock, it's mv squared over r, because it's causing circular motion, but it must be the sum of these two forces. They're both acting towards the centre, so they're both contributing to circular motion. R plus mg, that must be centripetal force, but that's not the case for the blue sock. The blue sock, my centripetal force, it must be equal to mv squared over r, because it's causing circular motion. What's causing it? Well, it's the resultant of these two forces. Now, r is going towards the centre of the circle, but mg is acting in the opposite direction. So, actually r minus mg. And from that, you could actually work out that this reaction force on the sock has to be greatest at the bottom of the drum, and it has to be at minimum at the top of the drum. And that is pretty much all there is to circular motion. If you can work with these two equations, find the information from the question, and substitute in, the rest of it becomes fairly straightforward. Keep an eye out for which other bits of physics, be it gravitational fields, electric fields, magnetic fields, or some basic mechanics from Module 2, keep an eye out on where you can find forces that are causing centripetal motion.